introduction to exercise 5I and exercise 5J conjoined. We've got encoding and decoding information and solving simultaneous equations using matrices on page 252 or 255 of your textbook. Now the first thing we're going to go over is our do now question. I'm going to zoom it over here so that we can see. Now with our do now question, we need to find the inverse of matrix A. Now there's two ways of doing this. You could define the matrix as, for example, the matrix A, and then find the inverse of that definition. Now, the thing with this question right here is that we don't need to define it. The reason why we define a matrix in our calculator is so that we can use it in later questions that don't require us to have as many calculations. So, for example, if the question said, here's matrix A, here's matrix B, find A plus B, find 2A plus B, find 3B minus A, whatever it is, then you want to define it because you don't want to have to type out the matrix every time. But if it's a once-off like this, we don't have to define it. We can go straight into finding the inverse. So I'm going to open up my calculator, go to the main section of my calculator. Okay. Now, just for demonstration, I'm going to clear everything on the calculator and also clear all variables so that you guys are aware. And then I'm going to go ahead and create that matrix. Remember, we go to math, keyboard, sorry, and then we go to math 2. And you can either press the row and then column matrix, or you can go straight into pressing the square matrix there. I'm going to put in the numbers, the elements of 8, 4, 3, and 1. Now normally, if you were to define it, you'd press this arrow and then define it as matrix A. However, I'm going to go ahead straight and go into power of -1 and hit enter. And that'll give us our inverse matrix. So I'm going to write here, and this is how I would write it in an assessment situation. I'll write A to the power of -1, or inverse of A, equals to -1/4, 1, and the bottom values are 3/4 and 2. Sorry, -2. There we go. So we end up with those values there. When we're using a matrix, I got this question last lesson. When we're writing a matrix, we don't want to use decimal places, right? So no rounding. We don't round our values in the matrix. We leave it in fraction form if possible, or if it's a nice, for example, 2.5, we just write 2.5. Okay, let's get into the content for today. Today we're looking at matrix encoding and decoding. The idea is that we can use matrices to encode information that we then later need a key for. Now, I don't know if you guys use WhatsApp. Have you heard of WhatsApp? Is that an old thing to you guys? Yeah. Those of you that have used WhatsApp before will have heard of two-end encryption. It's just a thing that comes up on the screen. Yeah. Basically, all it's saying is that both sides have a key, right? A security key, and this is not as relevant to this, but I think you guys will be interested anyway. So what happens is it's almost impossible to hack your messages from WhatsApp because WhatsApp needs a key in order to unlock the information that you have. But also your phone has its own key to unlock the information. You need both keys in order to unlock that information. That's why WhatsApp is, generally speaking, quite secure. Right? If I was to break it down into math terms, it's like saying, well, if I tell you what is 55 squared, it's hard, but you can work it out, right? If I give you paper, enough time, you can work out what 55 squared is. If I say, what is the square root of 1,325,000? That gets significantly harder, right? It's not a matter of just, if I have paper, I can work it out, right? So that's what we're working with, a key that makes it infinitely more difficult if you don't have it, okay? So we're going to start by defining what we know to be a letter and a number association. So in this situation, you don't have to write this down, but this is a very common way to describe these values here. Of course, we can't write A, B, C, D in our matrix, of course, because that's not something we can encrypt. So we first change our letters into numbers. So each letter of the alphabet, including space, even though it's not a letter of the alphabet, has a number associated with it, and we're going to manipulate those numbers using a specific key. Okay? Based off that, we can create a code in letters, change them into numbers, encrypt it using the key. And then once we want to decode it, we use the inverse of that key and do the opposite of what we did before. And I'll explain what that means later. So the question says, encode the message, meet me, then show how to decode and encode decode the encoded message using the matrix C, where C equals 2, 3, 1, 2. So that is our key. We've been given the key. Okay. So first thing I'm going to do is encode the message meet me. So I'm going to go ahead and define that as M. Can I get you guys to write this down? Thank you very much. Now, you could do this in a multitude of ways, but I'm going to do it this way just to make it very clear what we're doing and consistent. Remember, we can't encrypt letters, we can encrypt numbers, right? So, I'm going to go ahead and rewrite that as each value associated with the letter. So M, we look across our chart, we know M is 13, so I'm going to write 13. I know that E is our 5, so 5 and 5 again. T is 20, so I write 20 there. Space is 27. M, which we said was 13. E, we said was 5. And finally, space again. I'll give you guys a little bit of time to write that down. Good question. We don't want to use the number 0 because it does change our values a little bit. Yep. So we want to stick with space as 27. Okay. Now, what I'm going to do next, you don't have to do this in every question. This is just an explanation for how we would answer this question. What is the order of our matrix M? Yeah.
Will be 5, 3 5s.
So remember, the order is the dimensions of the matrix. How many rows are there in this matrix? 2. 2 by 4. Thank you very much. 2 by 4. What is the order of the matrix C? 2 by 2. Thank you very much. It is a square matrix. Now, can I write MC? Is that a valid matrix? No. Why not, Taya? Why are you shaking your head? Thank you very much. If I was to write MC, it would be the equivalent of a 2 by 2, 2 by 4, my apologies, multiplied by a 2 by 2 matrix, which cannot exist. We know that the numbers on the inside must be the same. And so instead, the only valid multiplication would be a CM. Okay. Now, I'm going to write that out. I'm not going to do it by hand. I'm just going to show you what it would look like. So, we have a 2, 3, 1, 2, multiplied by 13, 5, 5, 20, 27, 13, 5, and 27. So that was the matrix from before. All I'm doing is writing out the matrices as per the values given. Any questions? No? Okay. I'm going to multiply them. You do this in your calculator, so don't feel like you have to do this by hand. So we multiply them, and we end up with the values of 107, 49, 25. Don't worry, I'll give you guys a little bit of time to write this down as well. 121, 67, 31, 15, 74. Just referring back to the question earlier about why we don't, there we go, use 0 in place of a space. The problem is, if I say, for example, 3 times 27, and then I say divided by 3, you know the value is going to be 27. However, if I say 3 times 0, and then divided by 3, without me having told you that we multiply by 3 to begin with, you don't know what value it could have been. Because 3 times 0 is 0, 60 times 0 is still 0. So you want to stick with numbers that aren't 0. We end up with this matrix here, and that is the value CM. This is our encrypted or our encoded value. Without our key, without the matrix C, you cannot go back from this encrypted message into the original one here, which we could then change into the letter format. Okay? We can't do that because we need the matrix C. That is the key. Any questions about that? No? Okay. Now, can we divide matrices? No, we cannot divide matrices, so what do we do in place of dividing the matrices? Thank you very much. We times by the inverse. we times by the inverse. That's why our understanding of inverse comes in now. So the inverse of that, so I'm going to write C negative 1 times by Cm. So this is now the decoding step. Can I get you guys to write that down? Thank you. C to the power of negative 1, or inverse of C, times by Cm. Now theoretically, because remember, the inverse of C multiplied by C should give me what? Yep. So what's the matrix called when I have a leading diagonal as all 1s and everything else is 0? Starts with I. Identity, thank you very much. The identity matrix, which is the matrix equivalent of a 1. So if I multiply C to the power of negative 1 times by C, which has been multiplied by M, we should end up with just M. Right? It makes sense. If you wanted to rewrite it and get pedantic, you could write IM, which you know is the same as M. It's like the equivalent of saying 1x is the same as just x. So looking at simultaneous equations, a quick reminder, simultaneous equations means we're looking at two lines. In this case, they're both linear, so we're just looking at two straight lines where those lines intersect at some stage. So for example, if I have a line that looks like this and a line that looks like that, I know that the intersection, when we solve for these simultaneous equations, we end up with this red point right there, which we know will give us an x value, and we also know will give us a y value. So do note, in order to get the full marks, you must show the x and the y value. Okay. In this example here, we've been given a set of equations right here, where we have 5x plus 2y equals 21, 7x plus 3y equals 29. Okay? So we're focusing on changing this into a matrix first before solving it. To change it to a matrix, the first step I can do is to go from here to here, which is just to take out the terms with pronumerals on the left-hand side. So we end up with 5x plus 2y over here, and 7x plus 3y over here. On the right-hand side of the equal sign, it's just the constants there. Now, because of the property of matrices, I know I can just take out the coefficients and put them in their own matrix. Leave the pronumerals, x and y, in their own column matrix, and then leave the constants, the answers, on the right-hand side as per before. So all I've done is taken out the coefficients and left x, y by itself there. If I was to name the matrices, I've actually got A times capital X equals to C. Now we don't have to use these letters. These are just the letters that we've associated with them, conventionally. If you'd like to call them something different, you're more than welcome to. With that in mind, now that we've got A times X equals to C, what we can do is we just use the formula here, where X equals to the inverse times by C. Yes?
I didn't see there's two random letters.
Good question. Yes, they are just random letters we've used to describe them. Yeah. So we've got X equals to A inverse times C. So basically, what we've gone from this step here to this step, and all I've done is instead of divide by matrix A on both sides, which we can't do, we multiply by the inverse of A, which is the same thing, except instead of dividing, we're multiplying. And so we end up with X equals to inverse of A times by C. I'm seeing a very common mistake as I look through the classroom, where students will accidentally define a matrix before, maybe like 2 days ago, and complete the question now without defining it again, and they end up with some ridiculous answer. Please make sure you either clear all the variables at the start of every session, or you redefine the variables as you see fit. Alright, so we've got X equals to inverse of A times by C. You just put that in the calculator, as you can see here, inverse of A times by C, and you end up with a matrix that looks like that. Now remember, if the formula is X equals to, capital X equals to, you'll also remember that capital X is the matrix of X, Y. From there, we just read across X equals to 5 and Y equals to negative 2, and I have to write that step out. So just to reiterate, it is step 1, rewrite our equations as matrices, change that into just the two matrices there, use our formula right here, and then solve for x and y. Any questions? No? Lovely.